This is Dr. D. Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today the covering topic is problems on center of gravity of simple and composite bodies. The center of gravity of solid bodies. It is similar to the centroid for the plane figure as well as the lines. The centroid center of gravity can be determined by using the principle of moments. According to this law, the x coordinate of the center of gravity, it is equal to m1 x1 plus m2 x2 divided by m1 plus m2. This equation is used to determine the position of centroid for the x coordinate with respect to the reference line. If the density of the metal is constant, the modified equation can be taken as now rho v1 x1 plus rho v2 x2 divided by rho v1 plus rho v2 now. Since rho is a constant now, the modified equation is v1 x1 plus v2 x2 divided by v1 plus v2. Similarly, yc is equal to, we have taken as v1 y1 plus v2 y2 divided by v1 plus v2. That is, there is no, regarding the equations, there is no much difference between three-dimensional objects and two-dimensional objects, single dimensional objects. In two-dimensional objects, the modified equation for determining x coordinate of centroid is given by x is equal to a1 x1 plus a2 x2 divided by a1 plus a2. Similarly, yc is equal to a1 y1 plus a2 y2 divided by a1 plus a2 now. So the same equation here is applicable, but in terms of volumes now. That is, the area is replaced by the volumes now. Here for the composite figures, the object is divided into some regular segments such that each part, it may be having the shape of cylinder, hemisphere, right circular cone. We know the volume of the cylinder is equal to pi r square h, where r is representing the radius of the base circle of the cylinder, h is equal to height of the cylinder. The volume of the hemisphere is equal to, that is half of the volume of the sphere, which is equal to 2 by 3 pi r cube. Similarly, the volume of the right circular solid cone is equal to 1 by 3 pi r square h. Because by using, these are the values we have to remember for determining the center of gravity of the solids. If the composite figure is made up of different materials, in that case, the density of the metal is different. The modified equation for determining x by c are now, that is x is equal to, we can take it as m1 x1 plus m2 x2 divided by m1 plus m2. This m1 is equal to the density of the first materials multiplied by the volume of the first materials, so rho 1 v1 x1 plus rho 2 v2 x2 divided by rho 1 v1 and rho 2 v2. These are the modified equation for determining x coordinate. Similarly, the yc is equal to rho 1 v1 y1 plus rho 2 v2 y2 divided by rho 1 v1 plus rho 2 v2. These are the modified equations if the metal is made up of different materials having these sigmas, like when it is divided, it is in the form of cylinders, hemisphere and right circular solid cone. These equations are enough for determining the CG values. Here I am taking the plane now. Determine the center of this plane area. The given problem is a semicircular area is removed from a trapezium as shown in figure. Determine the centroid of the remaining area. Okay, here in this problem, since the section is not at all symmetrical about horizontal or vertical axis, therefore it is required to find out the coordinates of xc and yc with respect to the reference lines. Here the reference lines we are taking now. Generally the reference lines when you are taking, if the object is symmetrical, the symmetrical lines generally chosen as symmetrical lines. Otherwise, the line which is passing through the bottom of the figure in horizontal position, this is treated as x-axis and it is known as y-axis. That means with respect to this x-axis and y-axis, we have to locate the position of the centroid. Now divide this area, since it is a composite figure now, divide this area into some regular segments such that each segment is representing, it may be the rectangle or circle or the triangle or circular part. So if you just carefully if you observe, if you draw the line parallel to the base, this is a tetrahedron now, it is having one is here rectangle and another one is it is having triangle. That removed part is in the form of semicircular shape now. That is the object is divided into three segments now. Now the applicable formula is for determining centroid of this composite figure, xc is equal to, that is x coordinate of the centroid is given by a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3 required. But here if the area is removed, that is the corresponding area while determining centroid of that figure, it should be kept by using negative sign now. So the modified equations, if I take here it is the one segment and it is the second segment and it is the third segment. The modified equation is now a1 x1 plus a2 x2 a2 x2, just I am writing the equation a1 x1 a2 x2 minus a3 x3 divided by a1 plus a2 minus of a3 now. Similarly, yc is equal to, we can take it as a1 y1 plus a2 y2 minus of a3 y3 divided by a1 plus a2 plus a2 minus a3. These are the equations required to determine the position of the centroid with respect to the reference lines represented here as x-axis as well as the y-axis now. So where a1, a2, a3 are representing the area of corresponding segments 1 to 3 and x1, x2, x3 representing the position of centroid of that segment with respect to the y-axis now. So first we have to determine that area of each segment. So first I am taking area of the rectangle is equal to, that is length of the rectangle is given 40 plus 40, that is equal to 80 and height is given 30 mm. Hence the area is given by 80 into 30 is equal to 2400 mm square now. Similarly, the centroid of the rectangle is intersection of the diagonal or is at a distance of half of the length as well as the half of its height now. Intersection at that point. Hence, it is a position representing the, that is at a distance of 40 mm or 80 by 2 now. Hence, x1 is equal to 80 by 2 now, which is equal to 40 mm. y1 is equal to that height by 2, which is equal to 30 by 2, that is a 15 mm. The triangle is equal to, Area of the triangle is equal to half into base into height. Here, base is given now. According to this calculation, it is equal to 30 mm. That length is given here 80 mm. So, which is equal to 80 into 30 by 2, which is equal to 1200 mm square. It is representing the area of the triangle. So, xt is equal to, that is the position of the centroid with respect to the y-axis. From the base, it is at a distance of h by 3 now. That is the distance is equal to, we required h by 3. H is equal to here now 80 mm. That is 8 by 3 now. But we have to measure the distance with respect to the y-axis. That is 80 minus 80 by 3 now. Or 80 into, here h by 3 is given. The remaining distance is 80 into 2 by 3 now. From this relationship we got, which is equal to 53.3 mm now. Similarly, yt is equal to, again it lies h by 3. That is, here this is equal to given 30 mm. Here h by 3 is nothing but here somewhere it is there 10 mm. That is, if it is 30 mm, that is from this base it should be 30 by 3 given. But we required that y coordinate with respect to the x-axis. That means this distance is equal to 30 plus 30 by 3, which is equal to 30 plus 30 by 3 is equal to 40 mm. And third one, circle. The area of the circle is equal to half of the pi r square. And the center of gravity of the circle lies on symmetrical line of the semicircle. Hence, x3 is equal to, we can take it as 40 plus 40 by 2. Hence, it is equal to 40 plus 20, it is equal to 60 mm now. Y1 is equal to, that is the position of the centroid with respect to the x-axis now. That is by 3. It is equal to given by 3r by 4 pi now. So, by using the relations, you have to determine the position of the centroid of each elements 1, 2, 3, as well as the corresponding areas also with respect to the reference line. Here 4r by 3 pi is equal to, we got how much is 8.5 mm. The distance of center of gravity of the area with respect to the extreme vertical line now, that is the y-axis, is given by a1 x1 plus a2 x2 minus a3 x divided by a1 plus a2 plus a3. On substituting, a1 is equal to 2400, x1 is equal to 40, a2 is equal to 1200 into 53.3 minus of, since area is removed, here this area is represented by with a negative sign in the equations. Hence, a1 plus a2 minus a3, which is equal to 628.3 into 60. On just simplifications we got to, which is equal to 41.3 mm now. Similarly, the y coordinate of the centroid is given by a1 y1 plus a2 y2 minus of a3 y3 divided by a1 plus a2 minus 3. And substitute the values of a1 y1 a2 y2 in the equations, we got a1 is equal to 2400, y1 is equal to 15 mm plus 1200 into 40 minus of 628.3 into 8.5 divided by a1 plus a2 minus a3. On substituting the values, the equation on simplification we got yc is equal to 26.5 mm. Okay, this is a general procedure used to determine the centroid of the composite figure. Okay, one more problem taken now. A square hole is punched out of a circular lamina. The diagonal of the sphere being the radius of the circle as shown in figure. Find the center of gravity of this remainder if r is the radius of the circle. Here in these problems, we can select x-axis as well as the y-axis, that is reference lines, like this. Since the object is symmetrical about the horizontal lines, which is the passing through A, B, that is treated as the x-axis. Regarding y-axis, we can take it is maybe in the vertical line passing through the center of the circle, or it may be the vertical line passing through the point A like this. That is, this is treated as the x-axis, this is treated as the y-axis. Now, divide this segment into two parts. One is representing the circle and another one is representing the removed part A, which is in the form of square. So, the area of the main circle is given by pi r square, where assume this r is representing the radius of the circle. And the position of the centroid is at the center of the circle for the 1 now. Hence, x1 is equal to, we can take it as here small r now. That is a1 is equal to pi r square and x1 is equal to small r, that is x1 is equal to small r and y1 is equal to 0. Why? Because the horizontal line is passing through the diameter of the circle and it is also symmetrical line for that entire figure now. Similarly, for the second cutout circle, cutout square, area is equal to, which is equal to, that is the side length is required. If you take, if it is in the form of, that is like this is given now r. Okay, side is equal to now r into sine 45, which is equal to r by root 2. Similarly, it is also equal to r by root 2 now. So, the area of the cutout circle is given by, it is equal to r by root 2 into r by root 2, which is equal to r square by 2 or 0.5 r square now. So, here is given 0.5 r square. And x2 is equal to, here the center of gravity lies again the intersection of the diagonal now. This is given the radius of the circle, which is equal to, that is x2 is equal to, we can take it as now, x2 is equal to r plus r by 2, which is equal to 1.5 r now. So, it is given 1.5 r. Now, distance between the center of gravity of the section with respect to the point A now, because with respect to the point A means nothing but y-axis is given by a1 x1 minus of a2 x2 divided by a1 minus a2. So, on substituting a1 is equal to pi r square and x1 is equal to r minus a2 is equal to 0.5 r square into 1.5 r, which is equal to divided by a1 minus a2 pi r square minus 0.5 r square. On substituting the values of pi, we got x is equal to 0.05 r now. That is, here it is having almost at this position now. Okay, this is the position now. Here this values is not the correct now, some error is there now. It is almost equal to the 0.91 r. This is our required answer now. Similarly, for the composite figures now, solids now, a solid body formed by the joining of base of a right circular cone of height capital H to the equal base of right circular cylinder of height small h. Calculate the distance of the center of mass of the solid from its plane face when h is equal to 120 mm and small h is equal to 30 mm. Here it consists of one is the cylinder, right circular cylinder, and one more is here it is a cone now. These are the composite figures is given. So we are dividing this into two parts such that each is representing one is cylinder, one more is a right circular cone. But if we observe that figure, it is symmetrical about the vertical line, that is the axis is representing. Hence, this axis is treated as y-axis, and the bottom portion assume it is known as the x-axis. Okay, according to this reference line, so the x-coordinate of the center of gravity of the composite figure, that is xc, which is equal to 0 now. Only we have to represent the y is equal to how much it is now. Here the equation that is applicable here now, yc is equal to a1 y1 plus a2 y2 divided by a1 plus a2, that is for the area of the planes now. Since it is a solid, so the a is replaced by the volumes, that is yc is equal to, we can take it as now here v1 y1 plus v2 y2 divided by v1 plus v2. Since the object is made up of same materials, the density is a constant, that's why it is removed denominator and numerator. Now v1 and v2 are representing the volume of the first element and the second element, and y1 y2 representing the position of centroids of cylinder as well as the cone with respect to the base of the circular cylinder. Now v1 is equal to, that is volume of the cylinder is equal to pi r square h now. Pi r is equal to, assume this is the radius of the circle. Here according to calculate the distance, r is equal to radius of the circle, assume, and 30, which is equal to 30 pi r square now, mm cube now. Similarly, y is equal to, that is the position of the centroid of the cylinder, 30 by 2, which is equal to 15 mm. Similarly, for the right circular cone now, volume is equal to 1/3 of pi r square h, which is equal to pi by 3 r square into h is equal to 120 mm is given, which is equal to 40 pi r square mm cube now. And y is equal to, it lies at a distance of h by 4 from its base only. That means 30 plus h by 4, that is 120 by 4 now. That is we can written as now 30 plus 120 by 4, which is equal to 60 mm. The distance between the center of gravity of the section from the base of the cylinder, that is taken as a reference axis, that is the x-axis now. So yc is equal to v1 y1 plus v2 y2 divided by v1 plus v2. So v1 is equal to 30 pi r square and y1 is equal to 15 plus 40 pi r square into 60 divided by 30 pi r square plus 40 pi r square. On simplification, we got to r square is the common term in denominator and numerator. Hence, the value is equal to 2850 divided by 70, which is equal to 40.7 mm. That means from the base of the cylinder, the center of gravity lies on the axis at a distance of 40.7 mm, which is represented here approximately in the figure now like this now. And one more problem. A body consists of a right circular solid cone of height 40 mm and radius 30 mm, placed on a solid hemisphere of radius 30 mm of the same materials. Find the position of center of gravity of the body now. A body consists of right circular solid cone. This is known as a right circular solid cone. Having base radius is equal to 30 mm and height of the cylinder is equal to 40 mm. And it is placed on a hemisphere of the same radius. It is like this now. So find the position of the center of gravity of the body now. So the reference line we can take, that is the diameter AB or bottom of the figure. Okay, here I am taking, this is nothing but representing the bottom of the figure as x-axis. Since the object is symmetrically above the vertical lines, the CD line is representing the y-axis now. Hence, since the object is symmetrical about the vertical lines, the x-coordinate of the centroid, that is xc, is treated as 0 values now. So not required to do the calculation for locating xc values now. Hence we are putting concentration on y only, that is the position of the centroid with respect to the x-axis. Here the equation, it is y is equal to v1 x1 plus v2 x2 divided by v1 plus v2. This equation generally useful for determining position of the centroid, where v1 is representing the volume of the first part of the composite figure. Here we are taking hemisphere, and v2 is representing the volume of the right circular cone, here represented 2, and y1 and y2 y2 representing the position of centroid of first and second elements with respect to the x-axis. So now for the first figure now, the area is equal to the volume of this hemisphere is equal to half of the sphere. Hence v1 is equal to, we can take it as 2 by 3 pi r cube. 2 by 3 into pi r cube is equal to, r is equal to 30, hence 30 cube, which is equal to 18,000 into pi mm cube. Similarly, y1 is equal to, from the base, if you take this from the base, it is at a distance of 3r by 8 now. And so from the bottom position, this distance now becomes 5r by 8 now. That means y1 is equal to 5r by 8, which is equal to 5, r is equal to 30 divided by 8, which is equal to 18.275 mm. For the second figure now, that is right circular cone, the volume is equal to 1/3 of pi r square h, that is pi by 3 into r square h, pi by 3, r is equal to 30 square into h is equal to 40 mm, which is equal to 12,000 into pi mm cube now. Similarly, yt is equal to, it is at a distance of h by 3 from its base now, that is the center of gravity of the right circular cone lies on the axis, it is distance of h by 4 from the base now. That is the total distance is equal to, now here it is the radius is there, that is if you take from this point O, d is equal to 30 mm, the radius of the circle, plus 40 by 4 now, that is 30 plus 40 by 4, which is equal to 40 mm. Now substituting the values of v1 y1 and v2 y2 in the equations, y is equal to v1 y1 plus v2 y2 divided by v1 plus v2. We got v1 is equal to 18,000 pi into 1875, v2 is equal to 12,000 pi into 40 divided by 18,000 pi plus 12,000 pi. This pi is the common term. Hence, on doing this calculations, we got yc is equal to 27.3 mm. This is our required answer now. Center of gravity of bodies, one more, this cylinder we are taking now. A right circular cylinder of 12 centimeter diameter is joined with a hemisphere of the same diameter face to face. Find the greatest height of the cylinder so that the center of gravity of the composite section coincides with the plane of the joining the two sections. The density of the material of the hemisphere is twice that of the material of the cylinder. Okay, in this problem now, one is given right circular. This is right circular cylinder is given now. Diameter is given 120 mm. The height is given h values, assume. And it is joined with the hemisphere having diameter is equal to 120 mm. That is radius is equal to 60 mm is given now. Now determine the center of gravity of this composite figure. Assume this is the figure 1 now and it is the figure 2 now. Since the object is symmetrical about the vertical line now, hence this vertical line is represented as vertical reference lines and horizontal reference line is passing through point P. Hence, the x coordinate of the centroid is equal to the 0 since it lies on symmetrical lines, that is on y-axis now. So, in this problem is not required to determine the x values, it lies on vertical line now. Now, the second one is ycv required. It is equal to, since the material of the right circular cylinder as well as the hemisphere both are different, hence we are taking it is equal to rho 1 is assumed just representing the density of the first element, that is the hemisphere. V1 is representing the volumes. X1 is Y1 is representing the position of the centroid with respect to the horizontal line, plus rho 2 V2 X2 divided by rho 1 V1 plus rho 2 V2. This equation is required now. Here we are taking H is equal to the height of the cylinder. Now we are determining that is weight of the, that is mass of the first cylinder. It is equal to rho 1 pi by 4 d square into h now. That is the density into volumes now, which is equal to, we got now rho 1 it is there pi by 4, d is nothing but equal to 120 square h. It is equal to 3600 rho 1 pi h, which is equal to here as in this is equation number 1. Now case 2, y1 is equal to it is at a distance of h by 2 from the center now. Here this is the position. As in this is nothing but according to the problem is the 1. This is the treated as 2 from the position. That is 60 plus h by 2 now. It is represented here 60 plus h by 2 now. Regarding the second object, that is hemisphere now. The volume of the hemisphere is equal to half of the sphere, which is equal to 2 by 3 pi r cube. Since the material is made up of different materials, hence we require m is equal to, that is m2 is equal to density rho 2 by 3 pi r cube now. But according to our problem now, the density of the hemisphere is the twice that of the right circular cylinder. Hence, we are putting rho 2 is equal to 2 into rho 1, 2 by 3 into 60 cube now. From this relation we got to, it is equal to 2,88,000 rho 1 into pi values now. Similarly, y2 is equal to, here from the base it is having 3r by 8, hence the remaining height is it is equal to 5r by 8 now. Hence on substituting y2 is equal to 5r by 8, we got 5 into 60 by 8, which is equal to 37.5 mm. The distance between the center of gravity of the combined body from the reference lines, horizontal reference lines, that is the x-axis is given by m1 y1 plus m2 y2 divided by m1 plus m2, or you can take it as w1 y1 plus w2 y2 divided by w1 w2. Since g is a constant, hence it can be modified as m1 y1 plus m2 y2 divided by m1 plus m2 now. So, on substituting values of m1, y1, m2, y2 on these equations, but according to the problems, the center of gravity should be lies on the interface of joining cylinder, hemisphere as well as the right circular cylinder. That means it is at a distance of 60 mm from the point P now. Hence, 60 is equal to, that is yc is equal to, w just nothing but is given m1, it is equal to 3600 rho 1 pi h into y1 is equal to 60 plus h by 2 plus w2 is equal to 2,88,000 and y2 is equal to 37.5 and divided by, that is m1 plus m2, and substituting the values we got 2,16,000 h plus 1,72,80,000 which is equal to 2,15,000 h plus 1,800 h square plus here 1,08,000. Again on simplifications we got h square 1,800 h square is equal to, we got 64,80,000 or h is equal to 64,80,000 divided by 1,800 under square which is equal to under root of 3,600 which is equal to 60 mm. That means according to these problems, in order to lies the center of gravity of this composite section at the interface of, that is the joint face of the right circular cylinder and the cone, the height of the cylinder should be equal to 60 mm only. This is our required answer now. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.